Alright, today we're going to take a little time and review multiplying and dividing fractions. When I talk about multiplying fractions, I want us to think about what it really means, not the operation or procedure, okay? Half times a fourth. Anytime I think times, I always think of half of a fourth. Well, if I start diagramming this, half of, and I draw the circle in black here, and I have the quarter. Well, I only want half of that. I only want this little red pie piece. Well, how much of the circle is that? Well, if we were to divide that circle into equal pie pieces, I think you would see very quickly that there are 8, and we are taking the 1, or 1/8. The quick method, and again, procedurally on this, often is we just multiply numerators. 1 times 1 is 1, 2 times 4 is 8. It was a shortcut operationally for what we just talked about. And when we do this, we always want to think of an estimate before we start steps. 2/3 of 9/11. We're taking a part of something that's not even 1. It has to be less than 1. We're taking a fraction of something that's less than 1. Well, again, you could just multiply. 2 times 9 is 18, 3 times 11 is 33. But I like to think in primes. So I write 2 times 9 and 3 times 11. And often I skip this step in my head, but I write it then as 2 times 3 times 3 over 3 times 11. This is one product of primes. This is one product of primes. And when you have factors, you may cancel. The 3's cancel, and I get 2 times 3 is 6, and I get 11. 6 11ths. That meets my estimate. It's less than 1. 6 parts out of 11. Here I'm asking for 1 1/3 of 2 1/4. Well, 1 times 2 would be 2, and it's actually both are a little bigger, so it's going to have to be bigger than 2. First thing we got to do is convert it to improper fractions. 3 times 1 is 3, plus 1 makes 4/3. And again, this is a shortcut for this mentality. We are breaking apart 1 1/3 into 2 its sum, making a common denominator and adding them. And then 2 1/4 becomes 9/4. And again, I look for the primes. So I write 9 as 3 times 3. I don't break the 4's down because they match. And when I do this, I can cancel the 4's and I can cancel the 3's. And you'll see that I'm left with 3 over 1, which we call 3. Again, it meets my estimate. It's greater than 2. Again, multiplication leads us into division. Fractions are division, division are fractions. There is no difference. When I say 3 divided by 7, that is 3/7 the fraction. But here we're going to take 1/2 divided by 1/8. And we got to think of this. I want to do an estimate. We're going to take a half of a circle and break it into eighths. You're taking a small number but dividing it by even a smaller number. So our answer is going to be greater than 1. And again, how many eighths in a half? So if I draw a half and then I break it into eighths, 1, 2, 3, 4. The answer to this has got to be 4/8. It takes 4/8 to make a half. But again, a lot of times we talk about this from a procedural standpoint. And again, we know half divided by 1/8, small divided by smaller, has to be greater than 1. And I write this division as this fraction line, half over 8. And we know the answer is 4. How do we get from here to here? Again, we can do anything we want as long as we do it to top and bottom. 8 over 1, 8 over 1. When I multiply these, the bottom becomes 1. And the top here becomes 8 divided by 2, which is 4 over 1, which is 4. Often students just multiply by the reciprocal. But often you don't remember procedurally what to do. So if we write division as a fraction, we know the bottom has to go away. So again, 1 1/3 divided by 3/4. A big divided by a small. Answer has to be greater than 1. 4/3 divided by the fraction line, 3/4. Again, we use the reciprocal to make the bottom 1. 4 times 4 over 3 times 3 over 1, and that becomes 16 ninths. Again, it is multiplying by the reciprocal. If we remember, fractions and division are the same. You'll never struggle to remember which one to do.